The concept of artificial intelligence can be traced back to ancient times. Philosophers like Aristotle pondered the nature of the human mind and its capacity for reasoning. These early discussions laid the groundwork for understanding intelligence and logic. During the Enlightenment, thinkers such as René Descartes explored the concept of mind-body dualism. Descartes famously asserted, "I think, therefore I am," highlighting the significance of thinking and reasoning in defining existence. In the 19th century, mathematicians like George Boole and Ada Lovelace made significant contributions. Boole's work on symbolic logic and Boolean algebra provided a mathematical framework for reasoning. Lovelace envisioned machines that could perform tasks beyond mere calculation, hinting at cognitive capabilities. By the early 20th century, the theoretical foundations of AI were becoming more concrete. These foundational ideas would later inspire the pioneers of AI, who sought to turn these philosophical musings into practical reality. Alan Turing is often considered the father of computer science and artificial intelligence. In the 1930s, Turing developed the concept of a universal machine, now known as the Turing machine. This theoretical device could simulate any computation process, laying the groundwork for modern computers.
In 1950, I introduced the idea of the Turing test. This test aimed to determine if a machine could exhibit intelligent behavior indistinguishable from that of a human.
The Turing test remains a fundamental concept in AI, challenging researchers to create machines capable of human-like intelligence.
I coined the term artificial intelligence in 1956. I organized the Dartmouth Conference, where leading researchers gathered to discuss the potential of AI.
McCarthy's contributions extended beyond nomenclature. He developed the programming language Lisp, a cornerstone of AI research. Both Turing and McCarthy's visions shaped the early trajectory of AI. Their pioneering efforts laid the groundwork for the remarkable advancements that would follow. The Turing test, proposed by Alan Turing in 1950, marked a significant milestone in AI history. Turing's goal was to evaluate if a machine could exhibit human-like intelligence. A human evaluator would converse with both a machine and another human. If the evaluator couldn't distinguish between them, the machine passed. This test shifted AI research to practical implementations. It spurred advances in natural language processing and machine learning. While controversial, the Turing test has undeniably influenced AI. The Dartmouth Conference, held in the summer of 1956, marked the birth of AI as a formal field of study. Organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, it brought together leading researchers.
The proposal stated that every aspect of learning or intelligence can be precisely described for a machine to simulate.
The ambitious goals set at the Dartmouth Conference laid the groundwork for decades of AI research. Section 5, the first AI winter: skepticism and funding cuts. Despite the initial enthusiasm and progress in AI research, the field faced significant challenges in the 1970s and 1980s. This period, often referred to as the first AI winter, was characterized by skepticism, unmet expectations, and reduced funding.
Researchers struggled to make significant breakthroughs, and the limitations of early AI systems became apparent. One of the main reasons for the AI winter was the over-optimism of the early pioneers. They had promised rapid advancements and human-like intelligence, but the reality was far more complex.
Early AI systems based on symbolic reasoning and rule-based approaches failed to handle real-world complexity and uncertainty. The limitations of these systems led to disappointment and disillusionment among researchers and funding agencies.
During the AI winter, funding for AI research dwindled and many projects were abandoned.
The AI winter, while a period of difficulty, ultimately paved the way for a resurgence in AI research. Section 6. The AI rebound: new approaches and renewed interest. The AI winter eventually gave way to a period of renewed interest and innovation in the field.
In the late 1980s and early 1990s, researchers began to explore new approaches that showed promise in overcoming the limitations of earlier AI systems. One such approach was machine learning. which focused on enabling machines to learn from data and improve their performance over time.
Machine learning shifted the focus from explicitly programming rules to allowing machines to learn patterns and make predictions based on data.
Researchers developed algorithms that could automatically extract features from data, leading to breakthroughs in areas such as image recognition and natural language processing.
Inspired by the structure and function of the human brain, neural networks showed promise in handling complex tasks that traditional AI systems struggled with.
The AI rebound was also fueled by increased computational power and the availability of large datasets. Section 7. The rise of machine learning. Machine learning emerged as a transformative force in the field of AI. Unlike traditional rule-based systems, machine learning algorithms learn from data and improve their performance over time.
This approach enabled significant advancements in various AI applications, from image recognition to natural language processing.
These algorithms learn from labeled data, where each input is paired with the correct output. By training on large datasets, supervised learning models can make accurate predictions and classifications.
This approach has been successfully applied to tasks such as speech recognition, language translation, and medical diagnosis.
Unsupervised learning algorithms learn from unlabeled data, identifying patterns and structures within the data.
Unsupervised learning has been instrumental in discovering hidden insights in large datasets and improving the performance of AI systems.
Reinforcement learning, where agents learn by interacting with their environment and receiving feedback, has been used to train AI systems for complex tasks, such as game playing, robotics, and autonomous driving. Section 8. The emergence of neural networks. Neural networks have played a crucial role in the resurgence of AI. Inspired by the structure and function of the human brain, neural networks consist of interconnected nodes, or neurons, that process information.
These networks can learn complex patterns and representations, making them well-suited for tasks such as image and speech recognition.
Early neural networks were limited by the computational resources and data available at the time. It was not until the 1980s and 90s that neural networks experienced a resurgence, thanks to advances in computing power and the development of new training algorithms.
One of the key breakthroughs in neural networks was the development of deep learning, involving training neural networks with many layers to learn hierarchical representations of data.
Convolutional neural networks, CNNs, and recurrent neural networks, RNNs, are two popular types of neural networks that have achieved remarkable success. Section 9. Real-world applications of AI. AI has transitioned from theoretical concepts to practical applications that impact various aspects of our lives. One of the most visible examples is the use of AI in personal assistants like Siri, Alexa, and Google Assistant.
These systems leverage natural language processing and machine learning to understand and respond to user queries, making everyday tasks more convenient.
In healthcare, AI-powered systems can analyze medical images, such as X-rays and MRIs, to detect abnormalities with high accuracy. Machine learning models can also predict disease outcomes and personalize treatment plans based on patient data.
These applications are improving patient outcomes and reducing the burden on healthcare professionals.
In finance, AI algorithms are used for fraud detection, algorithmic trading, and risk assessment.
In transportation, AI is driving the development of autonomous vehicles, which have the potential to reduce accidents and improve traffic efficiency.
Recommendation systems powered by machine learning suggest movies, music, and products based on user preferences.
Section 10. Future prospects and potential impacts of AI. The future of AI holds immense promise and potential. As AI continues to advance, it is likely to have a profound impact on various aspects of society.
One of the most exciting prospects is the development of general AI, which refers to machines with human-like intelligence and the ability to perform any intellectual task that a human can.
While we are still far from achieving general AI, researchers are making significant strides in this direction.
AI has the potential to revolutionize industries and create new opportunities.
In education, AI can provide personalized learning experiences and support teachers in delivering high-quality instruction. In agriculture, AI-powered systems can optimize crop yields and reduce resource consumption.
However, the rise of AI also raises important ethical and societal considerations.
Ensuring that AI is developed and deployed responsibly is crucial to prevent unintended consequences.